The winter of 1946 arrived early in the hills outside Millfield, Pennsylvania. By November, temperatures had already dropped to 18 degrees below freezing. Snow fell in sheets that would not melt until March. Most residents had fled south or moved to Philadelphia after the munitions plant closure, but Cordelia Ashworth remained. The Millfield munitions plant had employed over 800 workers during wartime production. Built in 1942 to manufacture artillery shells for the European theater, it sprawled across 67 acres of Pennsylvania hillside. When the war ended in August 1945, government contracts ceased within 30 days. By Christmas 1945, the facility was abandoned. By summer 1946, the town's population had dropped from 2,000 to fewer than 50 residents. Those who remained were mostly elderly residents with nowhere else to go, or veterans like Lysander Ashworth, who had planned to work in the plant's civilian conversion program. That program never materialized. When Lysander died at Normandy, Cordelia lost not only her husband, but also their planned future in a community that was already disappearing. Her husband, Lysander, had died at Normandy in June 1944. By December 1946, Cordelia had been alone for 31 months. No pension, no relatives. The house where she had lived for 12 years was gone, destroyed when an experimental shell misfired during plant testing in October. She owned nothing but the clothes she wore and $17 in coins. The accident that destroyed her home was officially classified as a detonation incident during demilitarization procedures. According to War Department records discovered in 1968, plant supervisors were attempting to disarm defective shells when a percussion cap triggered a chain reaction. The explosion damaged 18 buildings and left a crater 43 feet across. Cordelia's house stood 70 yards from the blast site. Windows shattered, walls cracked, and the foundation shifted 6 inches. The structure was declared uninhabitable. War Department compensation procedures required proof of residence, property ownership documentation, and witness testimony. Cordelia possessed none of these. Her rental agreement had been verbal. The landlord had died of a heart attack 2 weeks before the explosion. The local courthouse had burned in an unrelated fire, destroying property records. Bureaucratically, she had never existed in Millfield at all. What happened next was discovered 61 years later. In 2007, municipal workers demolishing the old plant foundation found a metal box buried 4 feet underground. Inside were 43 handwritten pages, a hand-drawn map, and detailed measurements for what Cordelia called her winter fortress. These documents reveal how one woman turned industrial rubble into survival architecture that saved her life. The metal box itself provides clues about Cordelia's systematic approach to preservation. She had chosen a military ammunition container manufactured by Remington Arms in 1943. The container featured waterproof seals and corrosion-resistant coating. Before burial, she had wrapped the documents in multiple layers of waxed paper salvaged from military rations. This preservation method kept the papers legible for over 6 decades. The municipal demolition was part of a federal environmental cleanup program. Soil testing had revealed contamination from industrial chemicals used in shell production. The Environmental Protection Agency required complete removal of all plant infrastructure, including buried foundations and underground utilities. Without this federal mandate, Cordelia's documentation would never have been discovered. The pages, written in careful script on paper torn from a 1943 telephone directory, document every step of her construction process. Started digging November 15th. The first entry reads, ground frozen solid. Used crowbar from the plant wreckage. 18 inches down. Dirt softens. Need to reach 3 feet minimum. The handwriting analysis, conducted by forensic experts at Pennsylvania State University, confirmed the document's authenticity. Ink composition matched wartime formulations. Paper degradation patterns were consistent with 1940s newsprint. More importantly, the technical knowledge demonstrated in her construction notes reflected genuine engineering understanding, not modern fabrication. Cordelia had chosen her location precisely. The destroyed munitions plant left behind thousands of concrete blocks, steel beams, and intact pipes. More importantly, the plant's underground steam system remained partially functional. She had observed steam rising from certain points in the rubble field during the first cold snaps of November. Her notes reveal methodical planning. Steam pipe runs northeast to southwest, 12 feet from main break. Heat source confirmed. Snow melts in 18-inch radius, even at 0 degrees. Foundation stones available, 47 blocks, each 30 inches long, 18 inches wide, 12 inches thick. Sufficient for 8 by 10 shelter if stacked properly. But preparation meant nothing without execution. The first challenge was moving materials weighing over 200 pounds per block. Cordelia's solution demonstrates the difference between force and leverage. She built a pulley system using cables salvaged from the plant's loading dock. The loading dock had been designed to handle munitions shipments weighing up to 5 tons. Steel cables rated for this capacity remained intact after the plant closure. Cordelia's engineering notes reveal sophisticated understanding of mechanical advantage. 3-to-1 pulley ratio reduces required force by 67%. 200-pound block requires only 67 pounds of pulling force. Work increases proportionally, but force requirement stays within human capability. Her tool selection was equally methodical. The plant's machine shop contained hammers, crowbars, and measuring devices abandoned by departing workers. More importantly, she found a spirit level, essential for ensuring proper block alignment. Her notes emphasize, foundation must be level. 1-degree slope creates instability. 2-degree slope causes structural failure. Checked each block placement twice with spirit level. December 2nd, block movement system working, attach cable to block, run cable over steel beam, positioned as fulcrum, pull from opposite end. 100 pounds of force moves 200 pounds of stone. Moved 8 blocks today. Hands raw, but system proven. The physical toll of construction appears throughout her December entries. Blisters became calluses. Muscle soreness evolved into increased strength. She documented caloric requirements. Heavy construction work requires 3,000 calories daily. Reduced food supplies provide 1,800 calories maximum. Body weight declining, but work capacity maintained. Must finish construction before physical reserves depleted. Weather imposed additional construction challenges. December temperatures averaged 12 degrees below zero. Metal tools became painful to handle. Frozen ground resisted excavation, but Cordelia adapted her work schedule to environmental conditions. Work during midday warmth. Tools too cold before 10 a.m. after 3 p.m. 3-hour construction window daily. Progress slower, but avoids frostbite. Her approach differed entirely from conventional construction. Instead of building upward, she excavated downward. The shelter would be recessed 4 feet below ground level, with walls extending only 3 feet above surface. This design provided crucial advantages: protection from wind, natural insulation from earth, and concealment from anyone who might consider her resources worth stealing. December brought the first real test. On December 7th, exactly 5 years after Pearl Harbor, temperatures dropped to 34 below zero. Cordelia's notes from that night reveal both her desperation and her precision. Shelter 60% complete. Roof incomplete. Used salvaged tarps weighted with stones. Inside temperature 8 degrees. Outside -34. Difference of 42 degrees proves concept. Must finish roof before next storm. That night nearly killed her. The incomplete roof allowed heat to escape rapidly. Condensation from her breathing froze on the walls, creating ice buildup that further reduced insulation efficiency. Her survival depended on continuous movement, to maintain body temperature. She documented the experience. Forced to exercise every 20 minutes, jumping jacks, push-ups against wall. Physical exertion generates heat, but depletes energy reserves, cannot sustain this pattern. Roof completion now life or death priority. The tarp solution was temporary but instructive. Military tarps from the plant's storage facility were designed for weather protection but not insulation. However, when combined with air gaps, they created thermal barriers. Cordelia's innovation was layering. Bottom tarp on shelter floor. Middle tarp suspended 18 inches above floor, creating air pocket. Top tarp covers roof opening. 3-layer system traps warm air, prevents ground heat loss. This experience taught her crucial lessons about heat management. Heat loss occurs through conduction, convection, and radiation. Her ground-level shelter minimized convection by eliminating wind exposure. The earth provided natural insulation against conduction, but radiation heat loss, warm objects heating cold air, required active management through air circulation control. The roofing solution required engineering innovation. Conventional roofs need lumber, nails, and shingles, materials Cordelia could not obtain. Instead, she created a corbel arch using the concrete blocks. Each block was positioned to cantilever slightly over the one below, creating a self-supporting dome that required no additional framework. December 14th, arch construction complete. Each block supports the next. Final block, keystone, locks entire structure, tested by walking on roof surface. Holds my weight plus 50 pounds additional. Interior space, 8 feet by 6 feet by 5 feet high. Adequate for survival. Heat management became the next critical challenge. The steam pipe provided warmth, but uncontrolled heat creates condensation, which creates mold, which creates death by respiratory failure. Cordelia's solution was ventilation engineering. She installed a chimney system using salvaged metal ducting, creating a controlled airflow that maintained temperature while preventing moisture buildup. Steam provides base heat of 45 degrees. Chimney draws moisture upward. Fresh air enters through ground-level gap I left between foundation blocks. Air circulation prevents mold. Measured. Humidity stays below 60%. Safe for extended habitation. Water access required equal ingenuity. The municipal water system had been shut off throughout the area, but Cordelia realized that snow is simply frozen water, and steam pipes generate heat capable of melting snow efficiently. She constructed a snow melting system using metal containers positioned near the steam source. The snow collection process required systematic technique. Fresh snow contains more air and less actual water than aged snow. 1 gallon of fresh powder yields approximately 4 cups of water. Packed snow yields 6 cups per gallon. Ice yields 8 cups per gallon. Cordelia optimized her collection. Select packed snow from areas protected from wind contamination. Avoid snow near plant ruins. Possible chemical residue. Test melted water for clarity and taste before consumption. Water purification became equally critical. Even clean snow could contain bacteria or industrial residue. Cordelia's method combined boiling with filtration. Boil all water for 5 minutes minimum. Pour through cloth filter made from torn clothing. Allow to settle for 2 hours. Sediment falls to bottom. Clear water on top is safe for drinking. Never consume unboiled water, regardless of appearance. January 8th. Water system operational. Steel drum collects snow. Position 18 inches from steam pipe. Snow melts completely within 4 hours. 1 drum provides 3 gallons daily, sufficient for drinking, basic washing, cooking when necessary. Storage presented additional challenges. Water freezes at 32 degrees, but her shelter temperature often dropped below that threshold during severe weather. Her solution was strategic positioning. Keep water containers closest to steam source. Wrap in cloth insulation. Check every 2 hours during extreme cold. If ice film forms on surface, move container closer to heat. Frozen water means death within 3 days. The food preservation required similar innovation. Without refrigeration, fresh food spoils rapidly. Without freezing, preserved food remains nutritious indefinitely. Cordelia used winter itself as a storage system. Outdoor cache 18 inches underground. Temperature stays just below freezing. Food preserved but accessible. Dig down to retrieve supplies. Cover immediately to maintain temperature. But what separates survival from mere endurance is the maintenance of human dignity. Cordelia's notes reveal careful attention to cleanliness, routine, and mental health. She established a daily schedule, wake at dawn, check structural integrity, collect snow for water, maintain heat source, clean living space, write and journal, sleep at full darkness. Food presented the greatest ongoing challenge. Cordelia had no significant food stores when winter began. Her solution was improvisation combined with knowledge. She knew that the plant cafeteria had been abandoned with supplies intact. Multiple expeditions to the ruined building yielded canned goods, dried rice, and most crucially, salt for preserving any protein she might obtain. The cafeteria expeditions required careful planning. The building had suffered structural damage from the explosion. Roof sections had collapsed, creating unstable debris piles. But the basement storage remained accessible through a side entrance. Cordelia mapped safe routes. Enter through south wall opening, ceiling stable for 12 feet, step only on floor joists, never between them. Storage shelves intact in northeast corner. Her food selection demonstrated nutritional awareness. Canned goods provided protein and vitamins, but limited calories. Rice provided carbohydrates and calories, but minimal protein. Salt enabled food preservation and maintained electrolyte balance. She calculated requirements. Need minimum 2,000 calories daily to maintain health. Canned peaches, 80 calories per half cup. Rice, 200 calories per cup. Must ration carefully. Supplies must last until spring. January 22nd. Found canned peaches, label damaged but contents safe. Tested small amount. No illness. Also recovered. 2 pounds rice, 1 pound salt, various canned vegetables, rationed properly, sufficient calories for 3 weeks. Must locate additional sources before depletion. Hunting supplemented her food supplies, though winter conditions made it extremely challenging. Small animals, rabbits, squirrels, remained active even in severe cold. But hunting required tools she did not possess. Her innovation was trap construction using plant materials. Snare wire from electrical systems bent into slipknot configuration. Position along animal trails marked by tracks in snow. Check twice daily. Trapped animals die quickly in cold. The ethical dimension of survival hunting troubled her. Her notes reveal internal struggle. Never hunted before, raised to consider it cruel, but starvation also cruel. Animal death quick in properly set trap. Human death slow with malnutrition. Choose quick death over slow death. Apologize to each animal. Use every part. Meat for protein, fur for insulation, bones for tools. The psychological toll becomes evident in her February entries. Isolation and constant survival pressure affected her mental state, but she maintained sanity through structured thinking. Each day's entry includes technical observations, emotional reflection, and forward planning. This mental discipline proved as crucial as physical engineering. Mental health management required active strategy. Cordelia recognized early warning signs of psychological deterioration. Sleep patterns disrupted, dreams increasingly vivid and disturbing. Difficulty concentrating on technical tasks, memory lapses during routine procedures. These symptoms indicate stress overload. Must implement countermeasures. Her countermeasures were systematic. Daily schedule provided structure. Physical exercise maintained endurance. Mental exercises, reciting poetry, solving mathematical problems, kept cognitive function sharp. Most importantly, she maintained connection to her former life. Read Lysander's letters each evening. His voice in written words provides companionship and emotional anchor. February 3rd. Loneliness reaches dangerous level. Talking to myself frequently. Remedy: create imaginary conversations with Lysander. Discuss technical problems as if he were present. His voice in my memory provides companionship and second opinion on engineering decisions. This is not madness. This is survival strategy. The technique of imaginary conversation served multiple functions. It provided social interaction simulation, maintaining communication skills that isolation tends to degrade. It offered problem-solving assistance through internal dialogue. Most crucially, it preserved emotional connection to meaningful relationships, preventing the complete psychological isolation that destroys motivation to survive. Religious practice also supported mental health. Though never devoutly religious, Cordelia found prayer helpful for organizing thoughts and expressing gratitude. Her entries mention daily prayers. Thank God for steam heat, for yesterday's successful hunting, for hands strong enough to work. Prayer not about belief in divine intervention. Prayer about maintaining perspective and recognizing positive elements amid hardship. February's severe weather tested every system she had built. Temperatures remained below zero for 18 consecutive days. Wind speeds exceeded 40 miles per hour. Snow accumulation reached 7 feet, but her shelter held. The combination of deep excavation, thermal mass from concrete blocks, and controlled heat distribution maintained livable conditions. February 21st, worst storm yet. Outside, negative 18 degrees, 45 mile-per-hour winds. Inside, 38 degrees, no wind. Shelter proved successful. Snow covers roof completely, provides additional insulation. Design vindicated. I will survive this winter. March brought gradual warming and an unexpected crisis. As temperatures rose above freezing, snowmelt threatened to flood her underground shelter. Water management, previously focused on scarcity, now required flood prevention. Cordelia demonstrated adaptability by constructing drainage channels that diverted runoff away from her foundation. March 12th, snowmelt creating water infiltration. Emergency response. Dig drainage trenches on uphill side of shelter. Slope trenches to carry water past foundation stones. Crisis averted. Learned lesson. Winter preparation must include spring considerations, systems, thinking essential. By April, Cordelia had achieved what government agencies would later classify as impossible: solo survival through one of Pennsylvania's harshest winters, using only salvaged materials and human ingenuity. She had lost 37 pounds, but maintained health. More importantly, she had maintained sanity and dignity under extreme duress. Her final entries reveal plans beyond mere survival. April 4th, winter officially ended. Shelter proved successful, but this was proof of concept only. Next winter will be better. Know now what works, what fails, what improves. We'll document everything for others who might need this knowledge. Survival wisdom must not die with the survivor. That summer, Cordelia found work in Philadelphia and never returned to her shelter. But she never forgot the lessons. According to city records found in 1967, she sent detailed construction plans to the American Red Cross, the Veterans Administration, and 3 universities with engineering programs. Her letter to the Red Cross, dated July 15, 1947, explains her motivation. Gentlemen, enclosed are complete plans for emergency shelter construction using industrial waste materials. Construction requires no specialized tools, no purchased materials, and no professional assistance. One person can complete construction in 30 days, working 4 hours daily. Shelter supports 1 adult through winter temperatures below negative 30 degrees. Please distribute this information to disaster relief workers and veterans organizations. Future emergencies may require this knowledge. Respectfully, Mrs. Cordelia Ashworth. The Red Cross filed her plans in their disaster preparedness archives. University engineering departments used her designs in case studies about improvised construction. Veterans organizations distributed copies to members facing post-war housing shortages. Her knowledge reached thousands. But perhaps the most remarkable aspect of Cordelia's story is what it reveals about the nature of preparation itself. She had not planned for homelessness and winter exposure. She had no survival training or engineering education. Yet, when crisis arrived, she survived because she understood fundamental principles. Leverage multiplies force. Earth provides insulation. Heat rises and must be directed. Water takes the path of least resistance. Modern disaster preparedness focuses on stockpiling supplies. Cordelia's approach was different. She stockpiled knowledge. She understood that materials can be lost, stolen, or destroyed, but knowledge remains available as long as consciousness persists. In the moment of greatest need, knowledge becomes the tool that creates all other tools. Her success also demonstrates the power of systematic thinking under pressure. Each problem, shelter, heat, water, food, sanitation, mental health, received methodical analysis and solution. She never solved all problems simultaneously, but she solved each problem completely before moving to the next. Panic leads to rushing. Rushing leads to incomplete solutions. Incomplete solutions lead to system failures that can be fatal. The documents found in 2007 reveal one more crucial insight. Cordelia had not worked alone. Through February and March, she recorded conversations with other survivors in the area. 3 families had remained through winter, scattered across the valley. They shared resources when possible and information always. The Quincy family had established shelter in the abandoned railroad station 2 miles south. Harold Quincy, a veteran of the Great War, possessed hunting and trapping skills. His wife Meredith had nursing experience and understood mechanical repair from her work at a wartime medical facility. But they lacked Cordelia's engineering knowledge and systematic documentation methods. The Murphy family had occupied the old grain elevator north of town. Zachariah Murphy had been the plant's electrical supervisor and understood power systems. He had restored partial electricity using a small generator, but his family struggled with food preservation and water purification, problems Cordelia had already solved. The Kowalski brothers, recent immigrants from Poland, had survived similar hardships during the war in Europe. They understood scavenging, improvised construction, and resource conservation, but they knew little about American industrial materials and their potential civilian applications. February 28th met Harold Quincy from Valley Settlement. Shared construction techniques. He provided information about hunting rabbits. I provided water purification method using cloth filters and boiling. Knowledge exchange benefits all parties. Survival easier when wisdom is communal rather than individual. These knowledge exchanges were systematic and documented. Cordelia created detailed maps showing each family's location, their specialties, and safe travel routes between settlements. During severe weather, communication was impossible, but during brief warm periods, survivors would meet at predetermined locations to share information and resources. The cooperation extended beyond mere information sharing. When Harold Quincy injured his leg in a hunting accident, Cordelia provided warm shelter while Meredith treated the wound. When the Murphy generator failed, Zachariah spent 3 days at Cordelia's shelter, warm and fed, while planning repairs. When the Kowalski brothers found intact medical supplies in a bombed pharmacy, they shared antibiotics that prevented Cordelia's minor hand wound from becoming infected. This community aspect challenges popular narratives about individual self-reliance. Cordelia survived not because she isolated herself, but because she maintained connection with others facing similar challenges. Knowledge shared multiplies in value. Knowledge hoarded diminishes in effectiveness. The final lesson from Cordelia's winter lies in her motivation to document and distribute her discoveries. She could have kept her knowledge private, maintaining advantage over others. Instead, she chose to make her wisdom available to anyone who might need it. This decision reveals the moral dimension of survival knowledge. True preparedness is not about individual advantage over others. True preparedness is about developing capabilities that can be shared when crisis affects entire communities. The prepared person becomes a resource for community resilience, not just personal survival. Cordelia Ashworth lived until 1983. She died peacefully in Philadelphia, surrounded by family that included 12 grandchildren and 4 great-grandchildren. None of them ever experienced homelessness or hunger, but all of them learned the principles she had discovered: leverage, insulation, circulation, drainage, and systematic problem-solving. Her influence extended far beyond immediate family. After moving to Philadelphia in 1947, Cordelia worked for 34 years as a supervisor in a textile factory. During the factory's expansion in 1953, she designed an employee training program that emphasized systematic problem-solving and resource conservation. Workers who completed her program showed 30% higher productivity and 50% lower injury rates. The training program attracted attention from industrial efficiency experts. In 1962, Cordelia testified before a congressional subcommittee investigating industrial safety standards. Her presentation emphasized that worker safety improved when workers understood the engineering principles behind their tasks, rather than merely following procedural instructions. Her congressional testimony was published in the Federal Industrial Safety Handbook, distributed to factories nationwide. Thousands of workers learned problem-solving techniques that originated in her winter survival experience. The handbook remained in use until 1987, 23 years after her initial testimony. More importantly, they learned the character traits that made survival possible: patience under pressure, attention to detail, willingness to work with incomplete information, and determination to help others once your own safety is assured. These qualities cannot be stockpiled, purchased, or inherited. They must be cultivated through practice and applied through choice. The educational impact continued through multiple generations. Cordelia's grandchildren became engineers, nurses, teachers, and social workers. Each carried forward her emphasis on systematic thinking and community cooperation. Her great-grandchildren established the Ashworth Foundation in 1995, which provides emergency shelter training for displaced persons and disaster survivors. The municipal demolition that discovered her buried documents also revealed the remains of her shelter. After 61 years, the concrete blocks remained in position. The corbel arch had not collapsed. The drainage channels still directed water away from the foundation. Her engineering had proved sound even after 6 decades of weather and neglect. But the real test of her work is not its physical durability. The real test is whether her knowledge continues to serve people facing emergencies she never anticipated. Hurricane evacuees have used her drainage techniques. Earthquake survivors have applied her principles of improvised construction. Veterans dealing with homelessness have benefited from her systematic approach to resource management. Knowledge shared becomes knowledge multiplied. Wisdom applied becomes wisdom proven. Crisis survived becomes capacity developed. The war widow who built a shelter from rubble left behind something more valuable than concrete and steel. She left behind a methodology for transforming desperate circumstances into manageable problems. In an age of increasing uncertainty about supply chains, economic stability, and climate resilience, Cordelia's example remains relevant. Her tools were simple: observation, analysis, experimentation, and documentation. Her resources were available: discarded materials, natural energy sources, and collaborative relationships. Her success was reproducible by anyone willing to think systematically and work persistently. The lesson is not that everyone should build underground shelters from industrial rubble. The lesson is that human ingenuity, properly applied, can solve problems that appear impossible. The key is not having perfect materials, but using available materials perfectly. The goal is not avoiding all hardship, but maintaining dignity and capability, even in harsh circumstances. This is preparedness in its truest form, not the accumulation of supplies, but the cultivation of competence, not the building of barriers against uncertainty, but the development of skills for navigating uncertainty effectively, not the pursuit of individual advantage, but the creation of community resilience that benefits everyone when challenges inevitably arise. Voiceover closing. Cordelia Ashworth's handwritten notes remain on display at the Pennsylvania Historical Society in Philadelphia. Visitors often ask whether her techniques would work in modern emergencies. The answer is not simple. Times have changed, but physics remains constant. Leverage still multiplies force. Earth still provides insulation. Knowledge still creates capability. Modern emergency management professionals study her documentation as a case study in improvised engineering. FEMA training programs include sections on leveraging industrial waste for emergency shelter. The Red Cross has distributed translated versions of her techniques to disaster zones in 43 countries. Engineering schools use her corbel arch design as an example of structural innovation under resource constraints. But the techniques themselves are not the primary lesson. The techniques worked because they were based on fundamental principles, not memorized procedures. Cordelia succeeded because she understood why things work, not merely how things work. This distinction becomes crucial when facing problems that have never been encountered before. Contemporary survival experts emphasize equipment and supplies. Cordelia's approach emphasized understanding and adaptability. Equipment can be lost or stolen, supplies can be depleted or contaminated. But understanding remains available as long as consciousness persists. In unpredictable emergencies, adaptability matters more than preparation. The question is not whether her specific techniques remain relevant. The question is whether we still possess her mindset, methodical observation, systematic experimentation, persistent effort, and generous sharing of discoveries that could help others survive similar challenges. Climate change, economic instability, and supply chain disruption create new survival challenges that Cordelia never faced. But her methodology remains applicable. Identify available resources, understand their properties, experiment with applications, document successful techniques, and share knowledge with community members facing similar problems. Hurricane survivors in Louisiana have used her water purification methods. Earthquake victims in California have applied her rubble clearing techniques. Veterans experiencing homelessness have constructed modified versions of her shelter design. Refugees in multiple countries have adapted her systematic approach to resource management. Her methodology transcends specific circumstances. This is her legacy, not a blueprint for building shelters, but a framework for thinking clearly under pressure. In a world where the next crisis is always unknown but always approaching, such clarity may prove more valuable than any stockpile of supplies or fortress of materials. The final document in Cordelia's buried collection was a letter addressed to future survivors. Written in March 1947, just before she left for Philadelphia, it contains her ultimate lesson. Survival is not about avoiding hardship. Survival is about maintaining humanity while enduring hardship. Technical skills keep the body alive. Moral commitment keeps the soul alive. Both are necessary. Neither is sufficient alone. In our age of increasing uncertainty about supply chains, economic stability, and climate resilience, Cordelia's example remains profoundly relevant. Her tools were simple: observation, analysis, experimentation, and documentation. Her resources were available: discarded materials, natural energy sources, and collaborative relationships. Her success was reproducible by anyone willing to think systematically and work persistently. But perhaps most importantly, her approach was sustainable. She did not merely survive winter. She emerged from winter stronger, wiser, and more capable than when winter began. She transformed catastrophic circumstances into educational opportunities. She converted desperate isolation into community building. She changed personal survival into collective resilience.